Exponential equations are equations that have a variable and exponents. And obviously, if they have a variable and it's an equation, we're trying to solve for the variable. So let's look at a problem to start here. Okay? Let's start with this one. Just looking at this first problem, you can say, hey, that's kind of obvious. You know that x must equal 2 because 2 squared is 4. But how we solve this mathematically is what you do is you look at this on here on the right here, and we say, well, what is 4 as a power of this base of 2? And 4 is 2 squared, right? So I have 2 to the x equals 2 squared. And then what you can do is once you have the common base, and this by that I mean once you have this large number here is the same thing, 2 and 2, you can then write an equation with what is in the exponents only. So that's where I'm taking this x and this 2 and writing an equation x equals 2, and I've solved for x. Let's use that same strategy on the next problem. So again, I'm going to look at this and I'm going to write it as a power of 2. So I'm going to rewrite my 2 to the x up front, and I'm going to write 16 as a power of 2. So I might have to take out my calculator. If this was harder math, I didn't know what it was, and figure out what 2 times 2, how many 2's I multiplied to get 16. In this case, it's 4, right? 2 times 2 is 4, times 2 is 8, times 2 is 16. So that's 2 to the power of 4. Then, same strategy, you can take the take the exponents of x and 4, x equals 4, ignoring this common base again. Once there's a common base, you can ignore them, and you can simply write an equation with this part and get my answer. So I'm going to try that with the next problem. Again, bring down my 2 to the power of x. And 128, well, again, I know because I'm trying to solve this in terms of a power of 2 here, that I want to figure out how many 2's go into 128. And you're just going to take out a calculator and just divide that down and see how many 2's you get. Or you can put in your calculator 2 to the power of, and then sort of do a guess and check. If I do 2 to the power of 6, that's 64. But I doubled that would be 128, so I'm going to check. 2 to the power of 7 is 128. Excellent. So 2 to the power of 7. And then, again, because I have a common base now, I can ignore the base, and I can write my answer, x equals 7. Now, to take this a little, sort of as an easy step, it's almost a back step, but I just want to make sure we're really clear about that. If the variable's in the base here, where it's y the power of 2 equals 4, well, that's pretty straightforward, right? Because you just know you're going to square root both sides, and then you're going to get, let's say you wanted to do that, if you want to know what y is, right? And then y equals square root of 4 is 2. This next problem, though, you can't just square root it. Well, you could. You get y squared. But what you can do is think, okay, well, what number times itself 4 times is going to give me, times itself 4 times over is going to give me 1. Well, that one's pretty straightforward. That's just straight up. We know that 1's are the only ways you can get a power off that, right? But let's look at the last one. What you want to do is figure out, for this third problem here, what number times itself 3 times is going to give me 125. And I might look at my hint of seeing that it ends in a 5 there, and I might try 5 cubed, put that into my calculator if I can't do it in my head or don't know it off the top of my head, and that is correct. So y cubed equals 5 cubed, so y in this case equals 5. Those are the basics. Now let's get to some more complicated equations where we're doing some more sophisticated solving. Here's our first example problem. 2 to the power of x plus 1 equals 1/8. And it's good to, and you might even want to put that x plus 1 in a parenthesis to make sure you keep it up there self-contained. We're going to use the same exact strategy. We identify first the base, and the base I'm looking for is a 2. So I need to figure out what 1/8 is as a power of 2. Okay? So first I'm going to deal with just the 8. 1 over, and 8 as a power of 2 is 2 times 2 times 2, right? 2 cubed. So far so good? But it's not 2 cubed in the numerator equals, right? I have 2 cubed here in the denominator. So I have to be careful And remember my index rule, my index law, that when I bring this up from the denominator to the numerator, I change the sign of the exponent. So in essence, 1 over 2 cubed is 2 to the negative cubed. So far, so good? So now I'm going to rewrite this problem here on the left. I've got 2 to the x plus 1. And instead of writing 1/8, I'm going to supplant that, replace that with this, 2 to the negative 3. Okay? Next, once I've acknowledged, because right, I know that I have the same base here, so that's good. Now I can ignore the bases, and I can write an equation with just the exponents. So I write that out, and now I have a problem that I can solve for x. I can take away 1 from both sides. X equals negative 4. That is my answer. Let's do another one. Look at this problem. 4 to the power of x equals 1 over 2. Now, my variable in this case is actually on a base that's bigger than the base over here, so I have to be careful, and I always want to be using the smallest, most prime base between the two sides, right? On the previous problem, that base was over here, and I had to do my fixing over there, but this time around, I'm actually going to work with both sides here. So here's how we're going to go about it. I need to convert both of these into looking like something where I've got 2 to some power equals 2 to some power, because I need a common base. So I'm going to start first with my 4 to the power of x and figure out that's 2 to what power? Okay? So first I figure out what the 4 is, and the 4 is 2 squared. And it's 2 squared times x, right, to the power of x. So that means 2 squared to the x is 2 to the 2x. Make sure that makes sense to you, because that's what I'm going to replace this left side with. 2 to the 2x. Now I need to figure out this right side. So I start with 1/2, and I need that again to be 2 to some power. I'm going to use my index law, and I know that when I bring this up to the numerator, I change the sign of the exponent. Now the exponent starts out as a 1. So I'm going to bring it up and end up with 2 to the negative 1, right? So 2 to the, well, that equals 2 to the negative 1. So, fun. Oopsie. Used the wrong color. So this is 2 to the negative 1. You see how I've taken this and turned that into 2, a power of 2. And the right side I've turned into a power of 2. My bases have to be in the numerator, and they are here now, right? So now that I have the same base, I can ignore the bases, and I'm going to write that equation now using just the exponents. So 2x equals negative 1. Here is when I then solve for x. So I divide both sides by 2. This is just using basic inverse operations, and x equals negative 1/2. We're going to do one more. So first we did this top part here, and then we did this one. So now let's do a third quickly. So if we start with 25, x plus 1 equals 5. Same process. I need a common base. What's the common base of 25 and 5? 5, right? So I'm going to rewrite this side as 5 to a power, and 25 is 5 squared. Remember what I said before about putting that x plus 1 in parentheses? This is important. Okay, so I'm even going to put that up here like this, a little parenthesis around that. Equals 5. Now, 5 all by itself has a power. We don't usually write it, but what is that power? It's a 1. So now I have them to the same base, and I can rewrite that equation of 2x plus 1 equals 1. Then you're going to use standard order of operations to simplify, multiply out. 2x plus 2 equals 1. And now I'm going to use inverse operations, and I'm going to solve for x. And x equals negative 1/2. That's it.